So in this set of problems, we are looking at the difference between a proportional and a non-proportional linear relationship. Now, that's a lot of vocabulary, but it's actually a pretty simple concept, and it's pretty easy to identify each one. So for a proportional relationship, we're going to see y equals kx, or I've been writing it as y equals mx, where there is no y-intercept. It's just simply the y value, the x value, and then whatever the rate of change is. Now, again, that's a little bit wordy, but what's missing here is the y-intercept. So, if we see an equation that has no y-intercept at the end, we know it's a proportional relationship if it's in this format. For a non-proportional relationship, it's going to be in this y equals mx plus b format, and it's going to have a y-intercept. All right. Now again, a lot of verbiage there, but it's a pretty simple concept because the difference between the two is that non-proportional relationships have a y-intercept and proportional relationships do not. That's really the basics of what you need to know for this particular objective. All right, so let's take a look at question number 1. So in question number 1, you've got a data table as Roman numeral 1. The first thing you want to notice is when x is 0, y is 6. Well, what does that mean? It means it has a y-intercept. Well, if it has a y-intercept, it's a non-proportional relationship. So if you've got a hard copy of that paper, write non-proportional relationship on it. All right. For Roman numeral number 2, y equals 6x, there is no y-intercept, and it's written in this y equals kx or y equals mx format, so we know it's a proportional relationship. So write proportional relationship next to Roman numeral 2. Roman numeral 3, it's written in this y equals mx plus b format, so you guessed it, it's a non-proportional relationship. Write that on your paper. Number 4, we're given a graph, and we're actually not even given any values on that graph except for the origin. We don't know where the line crosses the y-axis, except that we know it doesn't cross at the origin, which means it has a y-intercept. If it has a y-intercept, that means it's a non-proportional relationship. So Roman number 4 is a non-proportional relationship. So when you scroll down and take a look at your answer choices, which of these represents a non-proportional relationship? Well, you should have written that down next to Roman numerals 1, 3, and 4. Roman numeral 2 is the only proportional relationship in that set. So in this question, we're given 4 answer choices, and we're asked to identify which of them does not represent a proportional relationship. So basically, which one is a non-proportional relationship? So this one's pretty cut and dry again. You're going to look for the equation that's formatted in this y equals mx plus b setup. Now, we're pretty fortunate in that answer choice D is set up in exactly this format. Now, the other 3 answer choices, especially answer choice B and C, they're written in a way that's a little bit deceptive because they're not written in a straight y equals format. But if you were to solve for y, which means you're isolating y, you would still end up with this y equals kx or y equals mx format. You would have y equals some number value and then x, and that's all you'd have. So in this case, D represents the non-proportional relationship. So for this problem, we're given 4 different graphs, and we're asked to identify which graph is the proportional relationship. Again, because it's a proportional relationship, that means it does not have a y-intercept. Or I should say the y-intercept is 0, so it won't be listed in an equation format. It'll be listed as y equals kx or y equals mx. In a graph, what we want to look for is where the line travels when x is 0. If it travels through the origin, then we know it's a proportional relationship. All right, so in this case, answer choice F is the only proportional relationship because it's the only line that's traveling through the origin. If it doesn't travel through the origin, that means it has a y-intercept that is not 0, and so it's a non-proportional relationship.